Okay, this is lesson 22, finding the area of quadrilaterals. Quadrilaterals is, again, just a four-sided figure. So the first one is just a regular old parallelogram. The definition of a parallelogram is two opposite and parallel sides. So the parallelogram is the same as a rectangle in essence because it is just base times height. Now, again, a parallelogram could look like this. So the height is represented a little different. It is from the top or one of the vertexes, which makes a perpendicular with a base. So that is what helps with that. Anyway, it's base times height. So if we're going to find the, say, the area of this one, and the base was 10 and height was 5, even if there's a measurement of 12 out here, this doesn't matter necessarily because we're looking at our height and our base. So area equals base times height, which is 50 units in this case because I didn't give an actual unit of measurement, units squared. Okay, so that's any parallelogram. That just means two opposite and parallel sides. So example 1. We'll do example 1A first. Gives us that diagram of a rectangle that is just a 22 by 12 inch figure, and again that's just the area is the base, so the base would be again 22 times the height of 12, so 22 times 12 gives us our answer of 264 inches squared. So final answer on that one is right there. On B, it gives us a square, excuse my drawing, gives us these little hatch marks, and that tells us the length of one side is 3 yards. And because of these little hatch marks, it means that each side is 3 yards. So again, area is base times height, so we just plug it in 3 times 3, which is just 9 yards squared. Final answer. Alright, so going over to C, that gives us a very nice example of a parallelogram. We have two lines going across. Oh, excuse me, that's a pretty bad drawing. So here we go, that one's parallel, and then these two are parallel. And it gives us a vertical height. Remember, it drops from a vertex down to the bottom and makes a perpendicular. It says this is 8 foot high and 15 foot wide. So again, it's just base times height, so 15 times 8. And that gives me 120. Remembering our label is 15 feet squared. There's our answer. Okay, next. Moving on to what a trapezoid looks like. Now, we remember that a trapezoid basically just looks like a triangle with its head chopped off. So if I had this triangle and I chopped it off at the top, that would be what a trapezoid looks like. So here's our trapezoid. Has two bases. In essence, it's top and a bottom is all it is. So on top, they give us a measurement of 20 inches, and on bottom it gives us a measurement of 28 inches. Now here's what's special about a trapezoid. It has to be parallel on top and bottom for this to work. And then it says that the vertical height from the vertex down, where it creates the perpendicular, is only 6 inches. So this is where we start to work. There's a formula that's for specifically trapezoids because this is not a parallelogram. Okay, so here's base 1, here's base 2. Now there's a formula that goes with it. It is the average of the bases. So it's base 1 plus base 2 divided by 2, and then multiplied by the height. So average of the bases multiplied by our height. So it's still base times height in essence, but we have to find the average of our bases first. And that will equal our height, or our area of a trapezoid. So I just draw this little trapezoid right here to show you what we're talking about. So base 1 is 20 plus base 2 is 28. Divide that by 2, multiply by our height of 6. So here we get 20 and 28, which is 48. 48 divided by 2 will give us 24. And then we just multiply 24 by 6. And that will give us our final product of 144. And this is still inches squared. Okay. Go to the next example. It'll give us another trapezoid. So it's a lot nicer when they tell you that the top and bottoms are parallel. So here it gives us a height of 11, a base of 30, 30, and 32. These are all centimeters. Centimeters. Okay, so average of the top and bottom, base 1 and base 2, so 30 plus 32 divided by 2, multiplied by my height. I get 31 for this, because that comes into 62 divided by 2 is 31, multiplied by 11, which will give us 341. Again, that's centimeters squared. Okay, on example 3, this is a little bit different of an example because it talks about rhombuses, and we got to remember what a rhombus is. It's basically just a squished square, so all four sides are equal, but it's kind of leaning. Remember, it's still a parallelogram, meaning this side is parallel to this side, and this side here is parallel to this side here, and all four sides are equal to each other. So in a rhombus, there's these things called diagonals. Well, in any shape that connects non-adjacent vertices, there's diagonals, but these are two in particular diagonals that can help us find something. So we'll call this diagonal 1, and that's the distance from here to here. We'll call this diagonal 2, and that's the distance from here to here. So there's two different ways to find area of a rhombus. It depends on what information you are given. If you're given the base and the height, so the height would be dropped down to right there somewhere. If you're given the base and the height, you would just multiply base times height, just like you would in any other parallelogram. If you are given the diagonals, then you use a different formula. So let's do the example of example 3a, where they give us a rhombus. Okay, remembering that it's a parallelogram. If I can get a pretty drawing would be better. Remembering that it's a parallelogram and that each side is equal to each other. Okay, that would remind us that it's a parallelogram as well. It tells us the height here is 9 and the base is 9.5. Okay, so all I have to do then is take my base. This is in centimeters, by the way. All I would have to do is then take my base, 9.5, multiply by my height of 9, and get my final answer of 85.5 centimeters squared. And that's all you have to do. It's just the same as a parallelogram. On B, however, they give you a different kind of rhombus, which is much more squished in this picture, but they again show you that all four sides are equal, so you know that it's a rhombus. But then they tell you that the diagonals, which I'm going to dot here, the first diagonal is 11, and the other one is 30. So 11 inches and 30 inches. So diagonal 1 times diagonal 2 divided by 2, or you may see it as 1/2 of diagonal 1 and diagonal 2. Either way is fine. So anyways, 11 times 30 divided by 2 is going to get us a grand total of 330 over 2, which reduces down to 165. And again, that's in inches, so it's inches squared. That's for rhombus. Okay. In carpeting, it gives us on example 4, it says here, it says 2 areas of a daycare need to be carpeted. The play area is shaped like a trapezoid, so here is the play area, just like that, and it says that there's a perpendicular right there. It is 35, and it says this base is 40, and this base is 26, and this is all in feet. Okay, so there's the play area. And the next place is in the shape of a rectangle. So the next one is 26 feet and 16 feet. Okay, it says use the diagrams. Here they are. Find the total area needed to be carpeted. So I just need to find the areas of them. Knowing that this is a trapezoid, I'm going to use base 1 plus base 2 divided by 2 multiplied by my height. So find the average of our bases plus 26 divided by 2, and then multiply it by our height, which was 35 in this case. 40 and 26 make 66 together. 66 divided by 2 is 33. So now I have 33 multiplied by 35, and it equals a grand total of 1,155 feet squared. Now I need to find the area of the rectangle. Rectangle, again, is just base times height. So 26 times 16, which equals 416 feet squared. Then to find the total of them, I'll just add those two together. Really simple. 1,571 feet squared. Okay, and that was the last example.